preference relation. So, just a simple question, what preference relation means? So you already have here. In the first page of your lecture, you have definition of preference relation. Yeah, what preference relation means? You can see like this here is written, preference relation refers to the way individuals rank or compare different options or choices based on their personal tastes, likes, and dislikes. So the key concept is here, personal tastes. You like something or you don't like something. So this is the most important key concept when we define the preference relation. So it means I prefer iPhone to Samsung or to like Galaxy. Yeah. So if I prefer iPhone to Samsung, there is some personal taste or likes. Why I prefer iPhone to Samsung, there is some specific personal reason for that. There is some specific personal reason. So why I prefer iPhone? Because of brand reputation. Because of brand reputation. I like. But maybe Levi likes Samsung to iPhone rather than iPhone. He likes Samsung. Why? He likes Samsung because of the camera quality. He wants to use that mobile phone for recording videos, taking photos. He's a photographer, for example. For taking photos, Galaxy Ultra 24 is much better than iPhone 15 Pro Max. So he has his own personal likes. I have my own personal likes. So if we rank one product over another product based on our personal like taste, based on personal likes and dislikes, we like summarize that one as a what? As a preference relation. So essentially, how people decide what they prefer when they faced with different alternatives. So this is the question: why we need preference relation? Do you have any reason that we should have preference relation? Why we need preference relation?
First of all, the consumer has model of consumption goods. So it kind of set a good item or not.
Yeah.
So he has a limited pocket of maybe money
Yeah.
to buy something. So in order to optimize his choice, he will choose according to his preference. So as we know, the consumer is not rich or able to consume every good in his bundle set.
Yeah.
He's gonna make some choice based on his preference.
Yeah.
So the preference relation allow us to say, okay, if he's going to buy this and this, it's better for us to which goods he's going to buy to maximize his utility. To maximize his utility. So the preference relation we add up to make.
Yeah, because so this is the key concept: different alternatives. Different alternatives. When in the market of smartphone, we have only iPhone. There's no Samsung, there's no Sony, there's no LG, there's no Xiaomi, there's no other company. Do we need still preference? Suppose in the smartphone market, there is only iPhone and just one type of iPhone, iPhone 15 Pro Max. There is no other smartphone. Do we need still preference relation there? No, because there is no alternative. So we need preference relation when we faced with different alternative. So it means what preference relation means? Preference relation means we want to prefer something to another thing. So it means we prefer iPhone to Samsung. So when there is no Samsung, you prefer iPhone to what? There's no other things to prefer. So either you buy iPhone or don't. But when there is other alternatives, then you need to think about which one you should buy, either buy Samsung or iPhone. Then we have preference relation because we have different alternatives. So this includes anything from selecting between different goods or services to making choices about leisure activities or investment. You have like $10,000. If you want to invest, then you have different alternatives. You can buy like some Bitcoin, yeah, and you can invest in the stock market. And within the stock market, you can buy Samsung stock, you can buy Apple stock, you can buy LG stock, you can buy like BMW stock, Toyota stock, which company you like. Again, there's the matter of like and dislike. So when we talk about preference relation, so it's very important and key concept. So in our daily life, although we don't think about this academic concept, from the early morning that we wake up to the late night that we sleep, in each point of time, we face two preference relation. So when we wake up, we prefer to wash our face first. Or when we wake up, we prefer to check our mobile phone first. Who send me a message and where I get some news. So until the late night that you decide when you should sleep, then instead of still watching some movie. So you face to preference relation. Why? Because there are many things that you should do. And we should make the best decision possible. You should prefer the best decision. So there are three types of preference relation. Weak preference relation, strict preference relation, and indifference preference relation. You know that weak preference relation, we can use this concept, at least as good as. For weak preference relation, when you say this term, X is at least as good as Y, it means we are talking about weak preference relation. And a strict preference relation, it means that strictly prefer one alternative to another one. It means X is strictly preferred to Y. So when someone says X is strictly preferred to Y, it means that we are talking about a strict preference relation. And we have indifference relation, which is X is indifference to Y. So ask me a questions about like choosing between two options. It can be anything. Just ask me a question. Do you want this or that? It can be anything. So suppose I have $100 and there is two options to buy. Just give me those two options. that can buy with $100? Just gave me two options that I can buy with $100. No, just ask me a question. For example, let me ask you this question. I gave you $100. Would you like to buy with this $100? Would you like to buy a very nice cloth, or you would like to buy a second-hand tablet for like writing your notes in the class? Which one? Cloth? So for sure. So then we are talking about a strict preference relation. So let me ask you a question, Levi. You have $500, and there is two options. One option is to go to Jeju Island for having some leisure time, having some party, and the next option is to buy a smartphone for like talking with your family. Suppose you don't have a smartphone now, and also you want to Jeju Island. Which one would you choose? Go to Jeju. So for 100%, yeah. So then you talk about the strict preference relation. And if you ask me that you have $500, and would you like to go to Jeju or would you like to buy a smartphone? I may say both of them is fine for me. Then I'm talking about which type of preference relation? This one. It means it doesn't matter for me to buy mobile phone or go to Jeju Island. So I get the same utility from both of them. So sometimes when you go to restaurant with your friend and you ask your friend like, would you like to have bibimbap or kimbap? He or she will tell you anything is fine. When she say anything is fine, what do you think? She's talking about weak, strict, or the indifference? Because it doesn't matter for him or her to use which one of them. So then we have some, in the consumer theory, we have some properties. So we cover preference relation, weak, strong, and indifference. So we have some properties. And for these properties, we call them axiom of choice. Inside the axiom of choice, we have completeness. So what does completeness mean? Just forget about those mathematical terms. Give me a real life example. What completeness means? Mm-hmm. 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 Mm-hmm.
I might be able to see I like banana
Mm-hmm.
more than food or
Mm-hmm.
so we call that.
Mm-hmm. Basically, when we say completeness, it means we have the power to make decision, and we are able to make decision. If someone will ask me, do you like to go to downtown tonight with me for having a party, or you would like to stay in your room and sleep or watch a movie? You have the power and you are able to make decision. You will say, okay, let's go. It means you made this decision to go to downtown to have a party with your friend. Or you may say, no, I prefer to stay at my room because tomorrow I have a presentation. So you made decision. Someone did not force you. You have this power to make decision by yourself. Or you may say, I'm fine with both of them. I'm fine with both of them. It means you do not prefer going to downtown to stay at home or stay at home to going to downtown. Both of them will happy you in the same level. You are happy with both of them in the same level. Because when we talk about consumer theory, the only things that we think mostly about that, how much happy I am, how much satisfied I am with making a decision. When going to downtown and staying at my room for watching a movie make me happy in the same level, so I may say both of them is fine. If I have a due date tomorrow to have a presentation in my class, so for sure staying at my room to making my presentation will make me happy more. Because otherwise, tomorrow I will be in a big stress. Although I will go tonight to downtown to have some party, but still I will not enjoy because I have something to do tomorrow. And there is a big pressure for that. So then you prefer to stay at home to do your assignment, to present your paper tomorrow or presentation because it makes you more happy. So basically when it comes to completeness, so you have this term in your lecture note. And here it says that like for each x and y, nx, either x is at least as y or y is at least as x or both. Both means indifference. Both means indifference here. So it means, so suppose there's one basket of apple, there's another basket of fruits. So when it comes to completeness, so you have this power when you go to the supermarket and there's two baskets of fruits, this one and this one. So you have this power to choose this one, or your indifference between both of them, and any of them is fine. You will just take, okay, it's good. Or you will see both of them and you will choose this one. So it means if this x is at least as good as this y, or if this y is at least as good as this x, or both of them is simply give you the same level of happiness. So mostly we will think about this one. So it says, it means that for any pair of goods or bundles of goods, a consumer is capable. It means it has the power. Have the power. Comparing them has necessary knowledge to evaluate alternative and expressing a preference for one over another. Simply, you have the power to make decision or you are able to make decision. It means basically the completeness axiom of choice or the completeness properties of consumer theory will say that there is no I don't know. There is no I don't know. That means you know which one is better. Although in real life, most of the times we say I don't know. Yeah? Have you ever said I don't know? Do you remember that sometimes you said this sentence, I don't know? So not the things are that. For example, I will ask you, which one do you like? I don't know. So it means I'm not able to make decision. When I say about which one do you like to choose, the red one or the blue one, it means I'm not able to make decision. So if I say I'm not able to make decision, so it means we do not satisfy the completeness axiom of choice. So when we do not satisfy them, so we will not have utility function later on. So the next one is transitivity. This is also a mathematical concept. So it means that if A is equal to B and B is equal to C, then A is also equal to C. A is also equal to C. Why? A is equal to B, C is equal to B is also equal to C. Why is like that? It means that, okay, there's 3 pens. Yeah? I prefer black one to blue one. I prefer blue one to red one. Yeah? Then I prefer black to red as well. So suppose this is not this is just ranking. So it means B, A is equal to B, C is equal to B, then A is equal to C. So it's just a mathematical concept. Why? Because when this side is equal, we have B, B, then this side should be also equal. It should be equal to C. So it means this is like transitivity. So it means if X is at least as good as Y, then Y is at least as good as Z, then this X is also at least as good as this Z. So, and also another one, we have another axiom of choice, reflexivity. Reflexivity. What this means? Living. What this reflexivity means? This one. Any bundle X is always at least as good as itself. What does it mean? This read marker is at least as good as this read marker. Am I right? If I buy just now from the market, this read marker is at least as good as this read marker. Yeah, so it means that is at least as good as itself, or at least as good as its identical bundle. But do you think in our real life always we consider this? Always is like that. We go to the supermarket. There is a baskets of fruit, for example, 2 baskets of fruit or 10 baskets of fruit, all of them exactly like identical, they have the same price. But why we still see which one is better to choose? They have same weight. Yeah, all of them is 2 kilogram. For example, this is 2 kilogram, this is 2 kilogram, this is 2 kilogram, this is 2 kilogram, this is 2 kilogram. All of them exactly the same weight, the same fruit. But why we see which one should I choose? Although they are completely identical. Weight, size, they came from the same tree, they came from the same time. So the thing is, it doesn't mean that this axiom should be always satisfied. In real life, most of the things we just break those rules. Although, for example, we go to the like electronic company, and there is some laptops, and there are 2 identical laptops exactly with the same capacity, that's with the same characteristic. Still, we see which one should I pick up. Still, we rank one laptop to another laptop which is identical to itself. So it means in real life, sometimes we do not satisfy this one. And these three axioms, in microeconomics, we say rationality axiom. Rationality axiom. So, and when you, yeah, and here, when you define the utility function, it says that suppose preference relation on X is equal to RL plus is rational, is strictly monotonic and continuous. By rational, what do we mean? In this definition that you have in your lecture note, that suppose preference relation on X is equal to RL plus is rational, strictly monotonic, and continuous. What rational means in this definition? Living. Transitivity and the last one, this one. So although I think in your lecture, Professor didn't cover this one. So this is another axiom, continuity. And basically when we think about continuity, it means when we draw the graph. For example, this is one utility function. This is another utility function. This is another utility function. And this is another utility function. All of them are representing utility. This is like U1, U2, U3, U4. Or this can be Cobb-Douglas. This can be linear. This can be quasi-linear. And this can be perfect complement. So this one, this one, this one, this one, all of them are continuous. Why? So I draw the graph for four types of utility function. Linear utility function, Cobb-Douglas utility function, quasi-linear utility function, and perfect complement utility function. And I claim that all of them are continuous. Why? And let's compare those one to these things. This graph. I start from here, then I go there. And I claim that this is not continuous. Why? So I have 5 graphs. 1, 2, 3, 4, and 5. I claim that this 4 graphs are continuous, but this one is not. Why this one is not continuous?
Why you see
Mm-hmm.
first?
Mm-hmm. Yeah.
So this is the first one.
Yeah.
Limit.
Mm-hmm.
Main.
Mm-hmm.
So for example, for all the functions, first,
Yeah.
we can see that there is no discount.
Yeah. Mm-hmm.
So as like the preference not changing like suddenly.
Yeah.
Because for example, when we take this is like at the moment as some change some gap like as something happened at this point.
Yeah.
So the continuity help us say to consider just come that's why we call that axiom.
Yeah.
So we consider that rules.
Yeah. So the thing is, when we say continuous, it means there is no jump in the graph. And when we start, drawing that graph. Without taking your hand from the paper, you can go till the end of the graph. But how about this one? Can I do like that? No, because there's a jump. I start here, then I should take out my hand, then again draw this one. If I don't take out, so then it should be like this. Again, it's continuous. But for this one, for this one, for this one, for this one, without taking my hand from the paper, I can just draw to the end. So, and also the another axiom. So we have two alternative formulation, okay. So you know upper contour set and lower contour set. What does it mean? Upper contour set and lower contour set. Upper and lower contour set. So let me draw this graph. For example, this is X. This is Y, and this is Z. Which one is upper contour set? Which one is lower contour set? And which one is indifferent set? For example, this is W.
Yes. So all the points.
Indifferent set. Yeah.
All Y. After
Okay. Sidra, which one is upper contour set? Y or Z? Okay, this Y is upper. Y is upper. Y is upper contour set. So it means Y, this Y is upper contour set. Yeah?
If you go up, you know all the goals we are going to choose there more proximity to X.
Yeah.
So Y we prefer Y to X because Y is located after like left to the right side to the right side of X. So the most we are far to the origin, the most we have utility drawing. So the preference is also like going up. So
Yeah.
Y is Z is lower contour set because like all the point there are just like come close to the origin. So
yeah.
Come close to X.
Yeah. Y, the set of Y is upper contour set because they are preferred to X. And YZ is lower contour set because X is preferred to them. And YW, like this P, any point here is indifference because you cannot rank them over each other. Either you consume this part or this part will make you the same level of happiness. Will make you happy in same level. So there's another axiom of choice continuity, still this one. So we have another one, local non-satiation. What does it mean? LNS. So I think you have, yes. Let me. Function convex. Yeah, it's written in the first page of your lecture note, I think for the second week. It says that preference relation on X is locally non-satiated if for every X, nx, there is an epsilon or very small value like exists y in big Y with y minus x is less than and equal to this epsilon such that y is strictly preferred to x. So let's ignore this definition. Why we need this locally non-satiation axiom for our preference relation? Why we need this? This is the main reason. We need locally non-satiated or locally non-satiated axiom because we believe that more is always better than less. More is always better than less. And locally non-satiation means that we do not have thick or circular indifference curves. Why? So this is circular indifference curve, this is thick indifference curve. But I said we do not have, we should not have, we cannot have. Why? Why we cannot have this kind of indifference curve? Rather, our indifference curve should be just a straight line, just a line, very like this kind of line, rather than like this with thick line or this circular curve. So this is thick indifference curve, this is circular indifference curve. But I said that we cannot have this kind of indifference curve. That's why our preference relation should be locally non-satiated. Can you tell me any reason why we should not have this kind of curve? And based on this one, more is always better than less.
Locally,
Mm-hmm.
that means x better than y. Always find
Mm-hmm.
which is better than this y,
Mm-hmm.
and even this epsilon gonna have another one better than this. So still we know that we have an economic homo economicus agent. So always think about himself and think about choose something better than. So
Yeah.
if it's not locally non-satiated, we have infinite kind of we could define, I think we could define like choices for one.
Yeah, let me tell you like this. We have one set X. And this one set X, there is 2 apples, for example. There is 3 bananas. And we have set Y. In this set Y, still we have 3 bananas. But we have, for example, 2.005 apple. Suppose that this epsilon is 0.005. And we say Y is better than X. Why is that so? Because in Y, we have at least more of one good. Although banana is three banana, but for in Y, we have 2.005 apple, but here we have just 2 apple. It means more is always better than less, even it's very small. More is always better than less, even it's very small amount. So it means 2.005 is better than 2. All the 0.05 is very small. And the thing is, for example, let's consider this 2 point. Suppose this is point A, this is point B. Here, x2, and here is x1. x1. And here we have, for example, 3x2, and here we have 2x2. Suppose this is our A set. A set, yeah. A set, we have 2 and 3. In our B set, we have like 3x1. Still, we have 3x2. You see, in the same curve, which is very thick curve, although in point A and point B, we have exactly the same amount of x2. But in point B, we have one more amount of x1. So it means B is better than A, although we have exactly the same amount of x2 in both of them. So that's why our indifference curve should be like this. Exactly is the same like that. Consider this point with this point. Here we have 2, here we have 3, but here we have 3 for both of them. So basically, we need local enunciation axiom in order to say that more is always better to less. So we do not have thick indifference curve, and we do not have circular indifference curve. If we have thick indifference curve and circular indifference curve, so it means we just ignore this axiom. So the next one is monotonicity. It's somehow similar to local enunciation. Still, we have same property, the same thing we want. So if I ask you a question, I think you had this kind of, yes, let me find, where did I put the paper? Here. So you have monotonic and strictly monotonic. What is the difference between those two? What is the difference between monotonic and strictly monotonic? I have also here weak monotonicity and strict monotonicity, or just monotonic and strictly monotonic. The basic idea is here. And the weak monotonicity, y is at least as good as x. It means y is weakly preferred to x. But in the strictly monotonicity, y is strictly preferred to x. So whenever in any definition or any concept, you see this one, weak monotonicity, it means y is at least as good as x. So anything, just two options. So maybe like z is at least as good as y, or p is at least as good as q. So it means there is at least as good as relationship. But when we have a strictly monotonicity, it means we have a strictly preference relation concepts. Strictly preference relation concepts. So this is also convexity that we already covered. So we have a strictly convexity and we have convexity. So the next thing is non-convexity. Also, I'll already show this kind of graph to you. And we have convex and strictly convex. So this is convex, this is strictly convex. What is the difference between those two? It's just like somehow similar, but there is a little bit different. You see, this is z, x, y. Z, x, y. But somehow in here, z, x, y, they're all of them located just in one straight line. But here, z is here, x is here, y is here, but still they are in the same set. Z, x, y is still in the same set. Both of them are convex, but this is strictly convex. That's just like weak convex, or just we can say convex. So these are the things, but why we need those kind of preference relation? Why we need those algorithms? This is the most important things. This is the most important thing. So why do we need these axioms? So we need rational axioms, as I told you, that completeness, transitivity, and reflexivity. This is a necessary condition for having utility function that represent the preference relation. In order to have a utility function that represent preference relation, our preference relation should be complete, transitive, and reflexive. And then the other things is monotonicity and local enunciation. Both of them is needed for the same concept. A consumer can always do a little better. It means more is always better than less. So why we need this function? In order to utility function is increasing or non-decreasing. What this means? It means always when we go up, we prefer upper part than lower part. Or at least we are indifferent than upper to lower, the same things that we are located now. So, and the next thing is convexity. Average or preferred to extreme. So it means, what does it mean, average or preferred to extreme? So let me ask you this question. You have like 100,000 won. With 100,000 won, you can buy 100 apples. 100 apples. Or you can buy, for example, 100 oranges. 100 apples, 100 oranges. Or you can buy 50 apples and 50 oranges. This is set A, this is set B, this is set C. I say that average is better than extreme, or average is preferred than extreme. Why? Levi, why average is better than extreme? No, just in real life. Why you want to consume 50 apple and 50 orange, and instead of consuming just 100 apple, no orange? Because actually we want to have everything even is listless, instead of having, like, if we want to buy 100 apple, if I eat this apple today, tomorrow, the next day, then after that the taste will be like very something repeated to me, and I don't like that. And the thing why average is better than extreme, because our taste is changing. Our like and dislike is changing. So it's not always the same. And continuity. Why we need this axiom? In order to have a continuous utility function. So if you consider the definition of utility function in here, so it says that suppose, in your lecture, suppose preference relation on X is equal to RL plus is rational. So it means this three. And this is strictly monotonic. It means this one. And it's continuous. Then you have a continuous utility function that represent this preference relation. So why we need to know all this preference relation axiom in order to have a continuous utility function. So these axiom are the condition for having a utility function. So if we know these conditions, it's very easy to prove representation theorem.